Hello everyone, I'm Sagar Dhotare. Uh, Today we will discuss about the second part of the rolling contact bearing. So in my first lecture, I have discussed about the classification of bearing, then the features and applications of the bearing, disadvantages of a rolling contact over the rolling contact bearing over the ball bearing. Okay, so before starting this lecture, I will request all of you please subscribe and like so whenever I prepare new lectures, it will automatically uh, link will be provided to you. Okay, so today we will discuss about the second part of the theory of rolling contact bearing. So we have to start with the basic static capacity. It is a very important aspect with respect to any bearing design because we are normally choose bearing from the manufacturer's catalog based on this value. Okay, so static load is the load acting on the bearing when the bearing is at stationary condition. When the static load is acting on a bearing, it produces some permanent deformation in the bearing, or you can say in the rolling element, and races, which increases with increasing load. This deformation is occurred due to the Hertz contact stresses. Normally, we define this deformation up to 0.0001 times of the diameter of the roller, or you can say ball. Okay, so basically the basic static capacity, or you can say basic static load of the bearing, is defined as the static radial load or axial load for thrust bearing condition, which correspond to a total deformation of a ball and a race at the most heavily stressed condition, or you can say stressed contact, equal to 0.0001 times of the ball or a roller diameter. Okay, the maximum static load the bearing can take without affecting its performance is the most important thing while selecting the basic static capacity of any bearing. Okay, this value of basic static capacity are given in a manufacturing catalog, as I said previously also. So based on this catalog value, we need to choose the bearing based on the application. As we have already discussed in the first lecture, which type of bearing used for somewhat what kind of applications. Okay, now to find out the basic capacity, there is a one equation is provided, that is a Stribeck's equation. It can provide the value of basic static capacity. Okay, we should know how much the basic static capacity should require, then and then only we can choose the standard value of um, bearing. Okay, so here they have provided basic assumptions are made for Stribeck's equation. So first one, these races are rigid and retain their circular shape even after loading. So still whenever a load maximum load when we apply, due to that load also it should not change its shape. So the circular shape of that uh, ball, or you can say roller, that should not be changed. Then second one, the balls are equally spaced. Okay, so and third one, the balls in upper half do not support any load. So out of the half portion, upper half portion will not take any kind of load or any kind of support. So lower one is directly engaging with the load carrying capacity. Fourth one, there is a raw, they have considered a single row of balls. Okay, so normally they have considered single row balls because it can directly use the actual load carrying capacity. Okay, so in figure they have shown the contact bearing, contact between inner race balls while we considering this equation. Okay, so here we are not discussing about the expression, we directly go through the equations. So first equation, which shows C0 is equal to KD square into Z divided by 5, where D is the diameter of ball. Okay, this is the simplest equation. Based on this equation you can find out the value, but if you are referring the design data book, the equation is different. Okay, and that you can find out based on the value of radial forces equivalent dynamic force. Okay, so when we discussing about the problem, we will briefly discuss on that. Now second equation is based on the rolling roller contact roller bearing. So it equation is K into DL into Z divided 5. So here L is the length of the roller, D is the diameter of roller, K is the constant which depends upon the radii of curvature at the point of contact and the moduli of elasticity of the ball and rest material. And the Z is the nothing but number of balls, or you can say rollers. So from this equation you can directly find out the static capacity of bearing. Now if there are number of, if the load, previously we are discussing about only one directional load, if there are two directional loads, for example axial as well as radial load, so it means that whenever you are considering two different loads, axial and radial, the equivalent load is the imaginary load which can equivalent to the sum of all applied load. ठीक है, तो ये कैसे, मतलब कैसे है कि इसमें अगर आप लोग रेडियल और एक्सियल दोनों लोड कंसिडर कर रहे हो, तो इन केस दैट whenever we are designing the rolling contact bearing, or when we are finding the static capacity, in that capacity we are only considering that the applied load is a radial load. Okay, and in case of thruster we are considering the pure axial load only. Okay, so because of that, if the other type of load is provided over there which couldn't consider, it is not like that. So that's why we are considering static equivalent load, so it can be give a combination, or you can say load equivalent to both. Okay, so here we can we can say that it is an imaginary static radial load which, if applied, would cause the same total permanent deformation at the most heavily stressed ball and race contact as that which occurs under the actual combined condition. Okay, so equation for that is x0 FOR plus y0 FOA. So here P is the equivalent static load, FR normally it is indicated by FR, which is static radial load, FA it is static thrust load, X is the radial factor, and Y is the axial, or you can say thrust factor. Okay, so normally in the table it is mentioned both factors, and based on the angular bearing the variation can be occur based on the normal angle, okay, value of alpha. One more condition is there. Whenever you are calculating the value of CO and P, that is static equivalent load, and uh, basic static load. So it should be like that. The basic static load capacity, or you can say the basic static value, is always more than that of equivalent static load. तो क्या होना चाहिए कि बेसिक स्टैटिक लोड का वैल्यू हमेशा ज्यादा होना चाहिए. Then and then only your bearing will be survive. Whatever the reliability or probability you are considering, that or whatever the hours of working you are considering, it will be easily satisfy that condition. Next one is a bearing life. Now bearing life is a divided into three segments. The life of only ball, the L10, that is 90% of the lot will be survived, the whatever the percentage we have considered, or whatever the life we are mentioned. And next one is a 50%. So we are considering that the 50% of group will survive, or it can take the maximum life of 30 to 50 times of minimum life. Okay, so we will discuss one by one. So first one, life of individual ball. The ball, the bearing may be defined as the number of revolution which the bearing runs before the first evidence of fatigue develops in a material of the rings or any of the rolling element. Okay, so it is considered that if whenever you are considering any bearing, it is founded in the unit of million revolution. So minimum 1 million revolutions can be uh, reached, or the performance of the bearing should be reached up to the 1 million revolution. Before that it should not fail. If it is fail, or if it is founded that the first evidence of fatigue, what is meant by first evidence? So it means that the crack propagations can be occurred. Okay, so fatigue can be start with the crack propagation, and it should not be happen before 1 million revolutions. Okay, so if the bearing is satisfied, or the any component, that is a ball, race, or cage, it should not be go into the small crack also, okay, minor crack also. If it can occur, then bearing life is, it is not 190%, or you can say that bearing is not suitable for selected application, so we need to change. Okay, if it allows that it to perform the given rpm, or you can say revolutions, number of revolutions, that is 1 million revolutions, then this bearing is suitable for decide application. Next one is the rating life of group. We know that whenever we are selecting any kind of bearing, it fails whenever the life is over. Okay, if I say I have select a bearing with a particular application, that it should perform at least, or it should sustain at least 10,000 hours running condition. Okay, if that bearing fails to complete the 10,000 rpm hours, and we can say this is not suitable for application. If it is completed that hours 10,000 hours, then we can say that the life of individual ball is acceptable, and the bearing is suitable for application. Now in case of 90%, or you can say L10 condition, or you can say rating of group, in same condition, if I chosen a lot of 10, or you can say 100 bearings, okay, so out of that 90 bearings can perform very well. Okay, it should not provide, it should not give any evidence of fatigue. They are very well work. Okay, but out of that, remaining 10% are failed to perform their work. Okay, so it means that the 90% of the group will complete or exceeds, or you can say complete the 10,000 hours. Okay, which is without uh, uh, or without showing any evidence of fatigue development. So जो क्रैक डेवलपमेंट के बारे में हम लोग बोल रहे थे, वो क्रैक डेवलपमेंट होने से पहले 90% बेरिंग्स ने अपना अपना 10,000 आवर्स का जो टारगेट था, और यू कैन से रिवॉल्यूशंस हमको चाहिए थे, that much million revolutions, so they can easily completed that. And this is the this we can say as a 90% life of the bearing. And here we can consider the reliability of that ग्रुप इज 90%। मतलब क्या कि 100 में से 90 पास हो गए और 10 फेल हो गए, तो उसके लिए हम लोग क्या कहेंगे कि 90% आप उस पर डिपेंड रह सकते हो। ओके, नाउ नेक्स्ट टर्म minimum life or median life, that is a M50. It is also used to donate the donate denote the rating life. It has found that the life which 50% of the group of the bearing will complete or exceed is approximately 5 times the life of 90% bearings will complete or exceeds. अभी ये मिनिमम लाइफ, इफ वी कैन से टर्म एज अ मिनिमम लाइफ, तो जो 90% हम हमारे जो 100 आउट ऑफ 90 बेरिंग्स थे, उसमें से भी 50% बेरिंग मोर देन 5 टाइम्स जो अपना नॉर्मल एवरेज वैल्यू है लाइफ का, उससे भी 5 गुना ज्यादा लाइफ अचीव करते हैं। ओके, इन अदर वर्ड्स वी कैन से द एवरेज लाइफ ऑफ बेरिंग इज 5 टाइम्स दैट द रेटिंग लाइफ। मतलब उसका जो मिनिमम लाइफ है 90% वाला, एज ए से 10,000 आरपीएम 10,000 हार्स, we are keeping that example. So 10,000 hours is the average life, so they can complete near about more than 10,000. If you consider 5 times, then it is 50,000 to 50,000 hours. Okay, so 50% मतलब जो 90 bearings है उसमें से भी 45 bearings they can sustain this much life. Okay, and out of another few bearings or 1 to 2 bearings will perform 30 to 50 times the life of मिनिमम लाइफ। मतलब उसमें से एक या दो ही बेरिंग्स ऐसे निकलते हैं जो 30 से 50 टाइम्स जो मिनिमम लाइफ रहता है। फॉर एग्जांपल इफ यू कैन से द मिनिमम लाइफ इज 5000 hours, then they will perform 30 to 50 times better than that of the given life. Okay, so these are the conditions, and these terms we will easily understood when we solve the examples. Okay, so I hope you fairly understood about these three lives. Now selection of bearing life. It is also very important thing about the bearing, because whenever we are selecting a bearing we need to consider a basic application, then the working hours, then what are the different type of loads are acting, only radial, only axial, or combined loads are there. So based on this the type of bearing we need to select, and based on the application the life is dependent. ओके, अगर वाइब्रेशन ज्यादा है तो वहां पे आपका बेरिंग का लाइफ हमेशा कम रहेगा। अगेन द एनवायरमेंटल कंडीशन आल्सो प्लेज एन वेरी इंपॉर्टेंट रोल फॉर बेरिंग लाइफ. So we have two different tables. Out of one is for automobile application. So in that for when we consider any automobile car, The bearing life is up to 50 million revolution. When you consider trucks, it's 100 million revolution, and railing roll cars, these considered as a 1000 million revolution. Now, based on the application of machine type, in machine sliding machines are there, then aircraft machines are there, then machine tools are there, for example agricultural machine, cranes, etc, etc. So various type of machines are available in industry. So based on the application, as I say, if you consider a bearing for aircraft, which we are not unable to use in a cranes, okay, so both are needed different bearings. Again, the working hours per day. Few machines are work in 8 hours per day, that is a one shift. Few will work with the 16 hours per week or 24 hours per week also. So it's totally depend how much hours the bearing is working. If it is continuously working, the life is always get reduced as the time of working get increased. Now next one, as we have already seen the static basic static capacity. Similarly, we need to find a basic dynamic capacity. So here, the basic dynamic capacity, we can say it's a constant stationary radial load which a group of apparently identical bearings with a stationary outer race can withstand with the rating life of 1 million revolutions of the inner race. Okay, so here in the dynamic load condition, or we can say how we can define the dynamic capacity. The dynamic capacity, we have defined that when we consider the imaginary radial load which is constantly applying at the particular point, okay, which is a group of apparent identical bearings with the stationary outer ring can be endure, or it can be change its shape for a rating life of 1 million revolution with only 10% failure. Then and then we can say it is a dynamic load. Now next, equivalent dynamic load. The rating life of the rating life in this definition is a 90% of the bearing will complete or exceed before the fatigue failure. तो इसमें क्या है कि जैसे स्टैटिक में हमने देखा था कि फर्स्ट एविडेंस ऑकर दैट इज 0.001% ऑफ द डायमीटर ऑफ द बॉल. तो इतना जो डिफॉर्मेशन है ये ऑकर होने से पहले बेरिंग अपना जो भी रेटिंग लाइफ दिया है वो कंप्लीट करता है. So here also similarly, but it can be axial load or radial load which is identical and it is not stationary actually. You can say dynamic load है, तो ये continuously ऑपरेट करता है. तो इसमें हम लोग क्या कहते हैं कि 90% of the bearings will survive the condition which we have seen, that the 90% bearings will be complete the 1 million revolutions and only 10% get failed. Okay, if it occurs, then and then only you can say this is it has a proper dynamic capacity. Now next one, equivalent dynamic capacity. Normally the basic dynamic capacity of the ball bearings is given in a manufacturing catalog. In manufacturing catalog, static and dynamic both capacities are provided, but they have considered that only pure radial load condition, as I previously said also, whenever the test occurred over the radial bearings, they normally consider only radial load. If thrust bearing is there, only pure axial load is considered. Okay, so now we have to convert that actual load, that is the two types of load, radial as well as axial, in the form of equivalent load, which can be applied radially with the same deformation, with the same extension. Okay, so hence when the balls are operating with some combination of radial and thrust load, it is necessary to convert the two components acting on the bearing into the single imaginary radial load, which is known as equivalent dynamic load. Okay, so to calculate this, or you can say a definition of the equivalent dynamic load, we have already discussed. So formula for that is P is equal to XVFR plus YFA into K. So with respect to the previous equation, the nomenclatures, or you can say characters, has been added in this. So P is equivalent load, FR is radial load, FA is the axial or thrust load, X is the radial factor, Y is the thrust factor, K is the load factor, or you can say service factor, or you can say application factor, and V is the rotational factor. So now the value of V is depend upon which type of race is rotating. If inner race is rotating, then value of V is 1. Outer race is rotating, then value of V is 1.2. And if the self alignment bearing we are using, then the value of V is 1. So depend upon application, the inner race rotate or outer race rotate. Normally, when we using a gear application, the shaft is continuously rotating, that outer race is stationary, and inner race is continuously rotating. Okay, but in the case of fan, or in the case of impeller, the inner shaft is stationary and outer impellers are get rotating. Okay, मतलब फैन अगर हम लोग कंसिडर करेंगे तो उसका जो इनर रेस रहता है वो कांस्टेंट रहता है, और only outer races get rotating. So based on the application, you need to choose a proper value of velocity factor, or you can say low rotation factor. So in the table we have provided the values that are based on the application and precision. We have provided the values. Commercial, for precision gearing, you can use 1 to 1.1. Commercial gearing for 1.1 to 1.3. Application with the poor bearing seal 1.2. Machinery with no impact 1 to 1.2. Machinery with light impact 1.2 to 1.5. And machinery with moderate impact 1.5 to 3. So depend upon application, you should choose a proper value of rotational factor. Next, load life relationship. So it is very important with respect to the design point of view. Now, whenever we designing any bearing, we are always considering the rating life of bearing is 1 million revolution, or it should be the 90% reliable. 90% reliable. So whatever we are value claiming, that out of that 90% should perform. So equation, when the bearing is subjected to radial load equal to the equivalent radial load, its rating life is given as L10 is equal to C by P raised to A. Now value of E is depend upon the type of bearing. It's a ball bearing or roller type of bearing. If it is ball bearing, then value is 3, and if it is a roller bearing, the value is 10 by 3. Okay, C is the dynamic capacity and P is the equivalent dynamic load. When we are referring the PRG, the equation is already present over there. We will refer this for calculation purpose. Now, the second equation, L10 is equal to LH10 into 60 into N divided by 10 raised to 6. So L10, it is the bearing life in million revolution. If we need to convert this million revolution life into the hours, this equation is used. Okay, so it directly provides the value. L10 is the rating life of bearing in million revolutions. LH10 is the rating life of bearing in hours with some constant speed. and n is nothing but that bearing speed. Okay, based on this equation you can find out if the million revolutions are given, we can convert that million revolution life into the hours. If a hours is given, we can convert into the million revolutions. Now this is a very important task, that is a procedure for selection of bearing from manufacturer's catalog. So the step-by-step information is provided over here, how to find out the bearing using a manufacturer's catalog. So initially, first stage, to calculate the axial and radial forces, or the uh, loads which is acting radially and axially. Okay, so if it is pure, we need to choose a particular, that is a ball bearing. If it is only axial, we need to use thrust bearing. If combined load is there, we are normally using DGBB or taper roller bearing. Okay, so depend upon the type of load, we need to select. Determine the diameter of shaft on which the bearing is mounted. So based on the diameter of shaft, we can find out the last two digits of the bearing specification. So we can directly choose the depend upon the type of load and the series of the bearing. If we are using 6, then it is a deep groove ball bearing. Okay, if we are using 0, then it's super lightweight. Then 1, it's a 2, it's a lightweight. 3, it's a heavy, and 4 is a extra heavy series. Okay, so we can find out the diameter very easily. Based on the diameter, you can find out the last two digits, and in from first step you can find out the type of bearing. Okay, based on that you can select the proper series of the bearing. Third one, select proper type of bearing from given application. As I mentioned, discussed just now, that how to choose that proper type of bearing. Now next one, selection of bearing is done by using trial and error method, because if we're changing the series, if we're using 61, 62, 63, 64, so out of 4 series they have a different value of static and dynamic capacity. So depend based on the trial and error method, you can choose whatever we require. Next one, find out the basic static capacity from or you can select the basic static capacity from the catalog. You can calculate or you can select from that. Now you have to find out the ratios, that FA upon FR and FA upon CO. So based on that ratio, you need to perform next step, that we need to find out the value of radial and thrust factors. After that, we have to calculate the value of service factor, which is we discussed just now before this slide, and based on that factor you can chosen the service life or load life or application factor, putting all the values, and in the equivalent dynamic equation you can directly find out the equivalent dynamic load. Now based on that load you can find out the expected life of bearing in million revolution, and after the calculation of the million revolution you can find out the dynamic capacity. Now this dynamic capacity we need to check whenever we are selecting the static capacity and dynamic capacity or chosen the bearing. It mentioned the static and dynamic capacity in that same row. Okay, so we have to check that the calculated value of C should be, or C0 should be lesser than that of the catalog value. If it is not happened, then we have to go back to step number 5. We need to change the type of or series of bearing and follow the same procedure. Finally, we need to find out that the value of C0 should be greater than that of value of P. Okay, so static capacity should be greater than that of equivalent dynamic load. Adjusted life of bearing. Okay, mostly the actual life, as we already discussed, we had to find out actual life and the rating life. So there is some differences, or always the actual life is lesser than that of rating life. So that for that purpose, some factors are affecting, or we need to consider those factors. So first factor, we need to consider the reliability should not be more than 90%. Okay, so whenever you are chosen any kind of bearing, the reliability you should up to 90% or and above, because if reduces the reliability, then the quality of bearing get reduces and the life of the bearing also get reduces. Second factor, different operating conditions. Yes, it is very normally it can reduces the rigidity of the material, and which may be start to the fail or preparation of crack propagation. So temperature, humidity, then magnetic field, radiation, so moisture, these are various factors which can affect over the operating conditions. Third one, requirement of different bearing material in specific application. Yes, it is necessary. If you are using with the magnetic field, you should not use the bearing with mm, having more ferrous. Okay, so in that condition you should go with normal non-ferrous material. Okay, so based on these applications you need to choose proper you need to calculate the actual value, which should be lesser than that of reliable value, or you can say L10 value. So equation is provided over here. Based on the equation and table number A and B, you can find out the uh, actual life. Now, next point, the equivalent dynamic load for bearing under cyclic load. We normally we are what we considering that only one segment is there. In that segment, the radial and axial load is there, so we get only one equivalent load. But when we considering a cyclic load, for example, automobiles or automotives, in that the various, or you can say four cylinder four stroke engine. So there are four strokes and four cylinders. So there are four segments. Now it generates four segments. So in each segment, the load carrying capacity is different. Then speed is different for each stroke. Whenever one in cylinder having suction, second having delivery, third and one having exhaust, and fourth one having expansion. So in each stroke there is variation. There is variation in the speed. Now this we need to convert into the single equivalent dynamic load. Okay, how we can convert it? By using the equation provided over here. Okay, so there are two equations we have mentioned here. So first equation provided over here, it can give a equivalent dynamic load, or you can say cubic mean load for uh, ball bearings, okay, which is subjected into the cyclic load. In second equation, it shows the equation for equivalent dynamic load or cubic mean load, where the roller type of bearings are introduced, or for rolling type of bearing, this equation we can use, where P are nothing but individual radial loads with successive RPM N1 and 2. L10 is the rating life of bearing, which is the addition of all the speeds in million revolutions. And C is the basic dynamic capacity, which is in Newton or kgf. If we are using PhD design data book, the values are in kgf, so we need to consider properly. Units should be equal. And L is the imaginary lives in a million revolution if the bearing is opened exclusively at the constant loads of P1, P2 to end. Okay, so here these equations we are using when the cyclic or multiple loads we are facing. Next one, equivalent dynamic load. So when the loads does not vary in steps, it never change the cyclic conditions and the steps of constant magnitude, but it varies continuously with respect to the time. At that time we need to follow these equations. Okay, so you can just look at the equations. For ball bearing, the first equation is given, and for roller bearing the second equation is provided.